So let's move on now to actual sensations and perceptions of vision. So this is as humans, our strongest and most common kind of sense. So let's break down how this actually occurs. First off, what is vision? Well, here's the vaguest possible definition of what vision is: the sense that allows us to process reflected light, which is pretty boring, to be honest. But if you think about the brain that we talked about in the last lecture, like half of our brain processes visual information, so it must be pretty important. So let's break this down as to what visual components are. Vision is just light, which is crazy to think about. Our brain is perceiving different colors and different information out of this light source. Now you'll notice here, this is kind of the overall diagram continuum of different types of light waves. So for instance, these are waves that are really short, have short wavelengths, and these are a lot longer. And the waves that humans can physically detect and physically see are in this teeny tiny little band. This is called the visible light spectrum, and you can see it enlarged here. So the visual light spectrum goes from about 400 nanometers to 700, and it represents the kind of rainbow that you're used to seeing. So the shorter wavelengths typically are perceived as purple, whereas the longer wavelengths that we can see are perceived as red. So the wavelength is what determines what color we're actually seeing. The way this happens is we get information, for instance, the white light from the sun, that's projecting all possible colors of light. So all wavelengths together make white light. And when you look at an object, that object itself does not have redness as a property. Light is going to bounce off that object. Now, when all of these white light colors hit the object is going to absorb most of those wavelengths, but it's also going to reflect some back. So in this particular, with most objects, the color that gets reflected back is the color that we perceive it as, because it's what actually gets passed to our eye. So the colors that you're seeing are just the wavelengths of light that are reflected off of an object. But once it gets to our eye, how does that work? So we gotta talk about some anatomy of the eye first. So to talk about its anatomy, we're gonna follow the path of light that it would take as it enters the eye. So these definitions are all in your book, but I'm gonna mention some of the key terms. So light is first gonna hit what's called your cornea. So this is the clear surface at the front of your eye, and it begins the process of directing light to the back. If you've ever kind of scratched your cornea, I hope you haven't, this is the clear surface that's right kind of protecting the front of your eye. So then we have light that goes through the iris. So the iris is the part of your eye that gives your eye its color. So whether you have blue eyes like me or brown eyes, it's this brightly colored circular muscle that adjusts the pupil. So your pupil right here is in the middle. It adjusts the pupil size to let certain light through the pupil. So the pupil is not a solid black dot in the middle of your eye. It's kind of a hole that light can pass through. And it's up to the iris. The iris is kind of like your gatekeeper that controls how much light can pass through that pupil. So once your light passes through the pupil, it's going to hit what's called the lens. So the lens is this clear structure that's kind of behind the pupil, and it's responsible for bending the light towards the back of the eye where we can actually process it. So there are muscles that are attached to the lens that allow it to change its shape and allows you to focus on either far objects off in the distance or near objects by bending the lens a certain way to change your depth of focus. So eventually, after the lens is kind of adjusting and projecting the light, it gets to the back of the eye, which is called the retina. It's kind of just that back surface area. And the retina is where all of your visual cells are, where the information can kind of start to get detected and get actually processed into a visual information your brain can read, a process called transduction.